All right, Earth Science class, we're going to start our first set of PowerPoints today. This one is on observing the night sky and exploring beyond the Earth. Now, I think the easiest way to do this is I'm going to just kind of read off of these PowerPoints here and be explaining along the way and explaining diagrams, adding things in. You should be following along in this video, so sit back, pay attention, and just listen up as I go through this PowerPoint. Electromagnetic radiation, so in this diagram here it's showing you the electromagnetic spectrum, and the longer wavelengths are to the left, and as you go towards the right, those are the shorter wavelengths. So some of these you may have heard of before, like infrared, ultraviolet rays, X-rays, microwaves, gamma rays. You may have heard of some of these, and the ones, like I said, on the left, so like radio waves, microwaves, infrared, they're more of a long wavelength, and we talked about wavelength a little bit before break, and also when we talked about the ocean, we said that there's like something called the trough and the wavelength. This is the same concept, but this is with waves not like the ocean waves, but with radio waves or microwaves, infrared waves, ultraviolet rays, X-rays, that sort of thing. All right, so I'm going to kind of read off of these slides here and be explaining as I go. The two most common forms of electromagnetic radiation are light and heat, both of which we get from the sun. So when you hear people refer to the sun's radiation, it is in the form of light and heat. So from the slowest to the fastest waves, they start with radio waves, then microwaves, infrared, ultraviolet, X-rays, and gamma rays. So those are from the slowest to the fastest. The longer your wavelength, the slower it is. The shorter your wavelength, the faster it is. So just using some of their examples here, like radio wavelengths are very long and they're very slow. Gamma rays are extremely fast and short. Before break, we also learned a little bit about telescopes, so now we're going to talk a little bit more about them. The easiest and cheapest way for us to observe the night sky is by using a telescope. That should be pretty obvious, right? Because it's cheaper than going and flying to the moon on a rocket or whatever. Using a telescope is a much easier and cheaper way to observe the night sky. There's also some really cool apps for iPhone. I'm sure there's some for Samsung and Android and all that too, but one of them I think is just called Night Sky, and if you take your phone out with the app any time of day or at night and hold it up to the sky, you can kind of move it around and you'll be able to see where those constellations and stars and different things are. Two types of telescopes that we had sort of learned about before break were the optical and radio. The optical ones study light, and then the radio ones study waves. And these are light and waves given off by objects in space. There's also something called the refracting telescope. And the way a refracting telescope works is light is collected and bent by an objective lens, which forms an image at the focal point. This brings in a lot of physics. We're not going to go into the crazy details of the physics of this, but when you guys take physics, you will understand this a little bit better. The typical shape of the lens is called convex. So there's a difference between convex and concave, but like I said, this gets into a lot of physics. So all I really want you to be familiar with is the refracting telescope, how it uses light that is bent. Reflecting telescopes. Light travels through the open end of the telescope and is reflected off of a concave mirror. The light then bounces off of a flat mirror and the image is created at the focal point. Again, this is a lot of physics here. I just kind of want you to be familiar with the different types of telescopes. Just know that there are different types. If someone refers to a reflecting telescope or a refracting telescope, just know that they are different. These are radio telescopes. You might be familiar with these. They kind of look like satellite dishes, like the ones that are on your roof of your house, perhaps. But these are used to study the radio waves that objects in space give off. They use a huge dish, as you can see, to reflect the waves to a focal point. They can use, wow, I can't talk. They can be used in good or bad weather, and they have helped astronomers map the universe. This particular picture kind of reminds me of that thing on Star Wars, like, when the Death Star blows up the planet Alderaan. That's what it kind of reminds me of. There are more expensive ways to explore space, as you all know. Before we figured out how to send humans into space, we used other devices. So things like space probes and satellites. There was something called Voyager 1 and 2 in 1977, which traveled to most of the outer planets. And then something named Galileo was a 2-in-1 probe in 1995, observed Jupiter's atmosphere. That's the year I was born. So it's, 24 years old now? 24 years ago we had Galileo. And then satellites revolve around other objects. I think you guys know that from the brief reading that you did on Tuesday. Most are used for weather, television, radio. Now, you may have heard of this before. This is the space race. So there is this huge race to get into space and learn more about space between the different countries. So the US was a big player in this. Russia was a big player in this. And in the late 1950s and early 1960s, the US was determined to beat Russia into space. Well, they beat us at that, but we were the first to land a man on the moon. So Russia was the first into space, but the US was the first to actually land a man on the moon. So take that, Russia. Just kidding. They both had great accomplishments. All right, the US began its space program with Project Mercury, in which John Glenn was the first American to orbit the Earth. Next was Project Gemini, where we actually went to the moon and observed its surface using robots. Finally, there was Project Apollo. On July 20th, 1969, Apollo 11 landed on the moon with Neil Armstrong, Buzz Aldrin, and Michael Collins. I feel like everybody has heard of Neil Armstrong before, but Buzz Aldrin and Michael Collins were there as well. All right, and here's pictures of some of these rockets here. We've got Mercury, Gemini, and Saturn V. These are some newer technologies. So after the Apollo missions, we wanted to find a more efficient way to send humans into space. So the space shuttle was invented in the late 1970s, which was a reusable vessel that could withstand re-entry into Earth's atmosphere. Space stations are laboratories actually in space that have everything needed to survive a prolonged period of time. So you can kind of think of it as base camp in outer space. And then Skylab and MIR. Skylab was a US one, MIR was Russia's, were very useful in the past. And now we have something called the ISS, which is the International Space Station, and it's currently assembled from the help of 16 different countries. So 16 different countries came together and helped put the International Space Station in place. The US has had over 39 shuttle missions to the ISS to take parts and people. And it is completed, so it's fully built. The US is now making trips to the ISS for routine maintenance and research with Russian cosmonauts. All right, that is the end of this PowerPoint.